young people, welcome back. Big in the house. Shout out to the sponsors and shout out to this beautiful textbook who's bringing us chapter 7, lesson 4, scientific notation, the learning objective. Express numbers in scientific notation. Number 2, find products and quotients of numbers expressed in scientific notation. Why did I swap back? Students will be able to do scientific notation. Yeah, concept, scientific notation, skill, add, subtract, multiply, and divide. So I think they're gonna have all of that in here, guys. Not the add and subtracting, but yeah, it's scientific notation. If I'm not mistaken, you've seen this before. It comes along in, I want to say, early junior high, 6th grade, 7th grade, 8th grade, and of course now we're getting into the big dog stuff. So with that said, guys, I'm gonna get this thing started. You know how we do. We got some awesome music. I'm so glad, because not my favorite lesson. There are so many opportunities to make a mistake in this, guys. You're moving a decimal to the left, you're moving it to the right. It only takes one slip of the brain to, ooh, I was supposed to go to the left. I was supposed to go to the right. But again, scientific notation, guys, is representing a number that's really, really big, compact, or a number that's really, really small, compact. So we're going to be using exponents. We're in the exponent chapter. Always remember, though, that that decimal has to be after the first digit. So here, I go from having a 3,400,000,000 to writing it as 3.4 times 10 to the 9. So I went 9 decimal places, guys. That was it. So that's why it's to the 9th power. Now, for number 2, I'm actually going to the right. I'm making the number, I'm making a smaller number bigger, right? So 3 and 12 tenths times 10 to the negative 7. I moved the decimal 7 places. Now why did I write it as a negative? No, because of the direction I went. $3.12 is going to be a whole lot smaller because the decimal is going to move when you have a negative 7, right? So for 3, you got 2,091,000. Well, to get that decimal to after one place, you notice I went 1, 2, 3, 4 spots. So 209.1 times 10 to the 7? No, there's 7 spaces. No, it's 4. I got a mistake that early? Oops. Right. Somebody's gonna catch that. All right, again, I already told you guys, it's that easy, right? And then we'll be like, I knew it was 4. But on the next one, guys, I'm putting the decimal where I want it, so you see how I placed it there? Now I'm literally 1, 2, 3, 4, 5, 6. I gotta count all those places. And I have, how many places did I just move it? 11. So 10 to the 11th power, but it will be a positive or negative, right? Think about it. You have a really big number, and now you're making it smaller, so it's gonna be positive. Think about it, multiplying a number times 10 makes it bigger. So I'll multiply by 10, so in this case 11 10, it's gonna get really, really big. So here, guys, I'm moving the decimal to the right. Nice and easy, there's only one digit, it's 8. So 8 times 10, and I already know it's gonna be negative because I want 8 to be super small, right? I'm gonna change 8 to a really, really small number. I multiply it by a negative 10 to the, how many little loops were there? 11 again. So to the negative 11th power. 8 times 10 to the negative 11th power. So guys, scientific notation is rewriting a number using the exponent. And yeah, it's fun, it's lovely. Wait till we start multiplying and dividing. So, all right guys, so moving the decimal to the right. So 1.42 times 10 to the, and here we go, let's count her out. 1, 2, 3, negative 3 power. So I I did not count for number 1 with 1, 2, 3, 4. I didn't count for number 2, but as you can see, number 6, I counted with you just because you got to know how many places you're moving your decimal, right? And again, if you're moving it to the right, make sure it's negative, to the left, so express each number in standard form. So now, guys, going from scientific notation into what's called regular numbers, standard form, right? So literally 2 and 1/10. I need to move the decimal 5 places to the right. It's getting bigger. So I do the loops and then I just add the circles. Now I can box that, or I can make it a little prettier and actually use, comma. 210,000, right? So for 8, you see I have a negative exponent, which means make the number smaller. What I mean by smaller, there you got a whole number of 8. It's like having 8 buckets, right? Well, you don't have 8 buckets. You actually have a very, 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 very little amount of anything in that bucket. It's so small, it's not even 1. So take the decimal, see how I done it? I go, smaller, right? Negative. So, which way we're gonna go? What's gonna make the number smaller? By moving the decimal to the, get that out the way, we don't want it in the way. 1, 2, 3, 4, 5, 6, 7. This tells me how many zeros I need. All right, and where the decimal is. There's there's a way to do this without doing it like that, but you just catch on, right? So, add all my zeros, put the decimal, and now I got a really, so it's not even, that's a super small number. That's like looking through a microscope, right? So for 9, again, the exponent now tells me to go to the left. So instead of having $3.63, I'm going to have 0.000000363. How I know how many zeros? There's only 1 place in front of the decimal, so this is that 5 more, that gives me a total of 6. But easy enough, guys, I believe. Counting my decimal places, just to be sure. You want to do that again, because remember, the only mistake you can make, guys, is literally you went the wrong direction or you put too many zeros. It's gonna happen, right? So for 10, it looks like 7 and 1500ths times 10 to the 8th, making it bigger. So I don't have $7, I actually have 715 million. I need 6 zeros. 1, 2, 3, comma, 1, 2, 3, comma, bam, 715 million. So I love it when I teach this, guys. I actually tell my kids, if you won the lotto, you wouldn't even know how much you had. 7.15 million. Huh? There it is, right? Me knowing and recognizing that I don't really get $7 when I win this lotto. I'm actually gonna get 7 million, right? So check it out, making the number bigger. For 11, we're gonna make it smaller. For 12, we're gonna make it bigger, but we're just moving our decimal and filling in what we need to. So for 12, we need 4 more zeros. Why? Because there's a decimal in 9. So move 1 place, 2, 3, 4, and I get 5 places, right? So I think we got this, guys. It's gonna get a lot more challenging. And I hope you have a calculator handy, because I know I did when I did this handout. So, moving on to the second portion, guys, where we're actually going to be doing some operations. We're going to be multiplying our scientific notation. So evaluate each expression, express the results in both scientific notation and standard form. So I actually have to write what the final value is, because 13, after I multiply my set of parentheses, 6 and 1/10 times 10 to the 5th, thank you, and 2 times 10 to the 5th. So when multiplying your scientific notation, keep things together. What I mean by keep things together? Well, keep your decimals together. 6.1 times 2. Keep your base and exponents together. So 10 to the 5th times 10 to the 5th. They're always going to be 10. The base is always going to be 10. So to me, that's 10 to the 10. I got that. And I can do 6.1 times 2. So So literally, that's what I mean, guys, by have a calculator handy. No need for you to stress and worry, right? 6.1 times 2 is going to give me 12.2. 10 to the 5th times 10 to the 5th gives me 10 to the 10th. So I get an answer of 12 and 2 tenths times 10 to the 10th. That's my scientific notation answer. So I can box that, but I also need to write it in standard form. So I need 9 more zeros. Yeah. I'm not even going to try to read that number. But 1, 2, 3, 1, 2, 3, 1, 2, 3, 122 billion. All right, let's get the number right. And yeah, I'm right. I'm so happy with myself. I'm writing it in words, right? 122 billion. All right, good. No boxes? Guess not. 14. Again, guys, 4 and 4 tenths times 10 to the 6th power. All times 1 and 6 tenths times 10 to the negative 9th power. So here's those negative exponents that came up before. But doing scientific notation, don't even think about fractions right now. Just think, keep the decimals together. Keep your base and exponents together. So 4 and 4 tenths times 1 and 6 tenths, I'm going to do that. And then of course, we just, well not just, but in the same chapter, we are multiplying exponents, right? So I'm going to do my first thing here, and I'm going to end up being 7 and 4 hundredths. And then of course, 10 to the 6 times 10 to the 9th, we know to add. So we're going to end up with a negative 3. Again, that's it written as scientific notation, but remembering negative means making smaller. So in my mind, I need 2 more decimal places in addition to that 7. Then put my dot. Oh boy, that's 1 too many. See what I mean? I believe that's 1 too many. But if you all find 1 decimal place on a homework assignment, and you understand the skill and the concept, don't worry about it. All of my editors are gonna get upset with me. He hates it when I make mistakes, does. All right, so 15, writing it out, recognizing what I'm gonna have in this one. It's still multiplying, so the exponents will be added. And of course, the decimals will just be multiplied. So 8 and 8 tenths times 3 and 5 tenths. And guys, I'm not trying to fool nobody. I'm pulling calculators out. Go ahead and set up your 10 to the 8th times 10 to the negative 13. So again, my brain knows multiply for my first set of parentheses, and then go ahead and subtract for the second. Pulled out a calculator, got 30 and 8 tenths times 10 to the 8 minus 13. 8 plus a negative 13, negative 5. Now again, since the scientific notation has 10 to the negative 5th power, I'm going to rewrite it knowing that 30 is going to get much smaller. The decimal is going to move to the left, right? So this is me going, I need 4 more. I don't know why that extra decimal is there, because I am all about mistakes on this video. Guys, scientific notation does have a lot of opportunities for you to put the decimal in the wrong place. I'm going to have 2 decimals in 15. I'll tell you how. Because I'm human. I was going to crack up about this one, y'all. You better not watch this video. But anyway, 16. 10 to the, what we got here? 4, negative 4. So multiplying the decimals. Then of course multiplying your base and powers. And maybe I will slow down and get a proper solution to this. Or actually not a solution, and answer. We're just simplifying, right? 10 to the negative 4. So, calculator is going to go ahead and come on out. Don't need a calculator to do the second set of parentheses, but definitely the first, right? 9 and 72 hundredths times 10 to the, and guys, again, positive 4. 8 plus a negative 4, I have more positives than negatives, and the rules. Again, this time it's going to get bigger, so 2 decimal places plus another 2. There we go. So you notice I was doing these little loops earlier. That was so I could actually put zeros inside of those loops. This kind of helps me not to mess up, all right? This isn't a standardized test. This isn't even a test. This isn't multiple choice. It's just you here getting some help. So hopefully you're gaining the skills and those mistakes won't happen. 17, we got an exponent to tell me I got the same thing times itself. So a good rewrite to make it clear as day. So 2 and 2/10 times 10 to the -3. And why not again? 2 times 2. I'm sorry, 2 times 2. 2 and 2/10 times 10 to the -3. So 2 and 2/10 times 2 and 2/10 gives me 4 and 8400ths times 10 to the, now -3 plus -3, you got it. Gives you more negatives, -6. So now I'm going to move that decimal to the right or to the left? To the left, making it smaller, right? 8, 4, good. All right, guys, so definitely don't have room for 18 anywhere. I'm going to go ahead and box both the scientific notation as well as the standard form. And I think I'm either going to leave you 18 or I got to make some room. And let's get some room. And let's go ahead and get 18. So 18, again, just like 17, recognizing that 3 and 4/10 times 10 to the second, all squared. See that? All squared. So meaning what's in the parentheses is all going to be squared, right? So again, guys, nothing new here. I'm literally figuring out what 3 and 4/10 times 3 and 4/10 is. And if you don't have a calculator, guys, I'm going to give you a little what's up. Get a calculator. Use a calculator. So 115 and 6/10 times 10 to the 4th. And guys, I believe that's enough on this top section. Looks like I'm trying to erase and things are looking funny. No, I wasn't right. Don't ask me. I just commentate. I don't know who did this handout. Making mistakes from minute 1, to minute 15. Yeah, maybe 3 minutes, huh? Yeah. Yes. You're gonna continue to rock with me, guys, because if you did 18 of these so far with me, that is excellent. But we've got division to do. And what I mean by we've got division to do is we did scientific notation with multiplying. So now we got scientific notation with dividing. We're gonna continue to break it into 2 parts. The part with the decimal, and then of course the part with the base and exponent, or 10 power, base 10 basically. Base 10, the base is 10. So again, guys, have a calculator handy. I'm gonna be honest, sometimes I use a calculator, sometimes I think I'm smart. I'm just doing it like I was in 5th grade, paper and pencil, right? Lining things up and multiplying. But don't be afraid to make a mistake, because mistakes are going to always help you learn something that you probably don't know yet, or you're still learning. So, broken in the first part, 9 and 2/10 divided by 2. And then the second part, 10 to the 8th divided by 10 to the 6th. Now, I have -8 and -6, kind of looks like a dot, but hopefully you're with me here, and it's going to be 10 to the left. And again, here's where the rules are important, guys. When it's division, we got to subtract our exponents. -8 minus -6. Integer rules. -8 plus 6. Showing the parentheses for the base 10. Right? So 4 and 6/10 times 10 to the left. And again, hopefully, I'm going to show you -8 plus 6 is going to end up giving you -2. So again, they want us to write it in scientific notation. So here we go. I'm going to get a box around that, hopefully. We're going to have to write it in standard form, meaning we're going to make it small, but only 2 decimal places. So once I pass the 4, I need 1 more, so that's where the 0 comes in. So 0.046. No worries about boxing the scientific notation. But for 20, again, 4 and 8/10 times 10 to the 4th, all divided by 3 times 10 to the negative 5th. So, again, recognizing when seeing scientific notation, I can break it off. Let's do the division of the decimals, or in this case, the decimal and the whole number. And then with our base 10, we'll work with that separately. So moving horizontal this time. Again, to me guys, as you kind of see, 3 goes in 4, 3 goes in 18. But 10 to the 4th divided by 10 to the negative 5th. So, got that calculator? And it looks like, I'm going to say 1.6 times 10 to the 4 minus, right? Rule of subtraction, a negative 5. So 4 minus a negative 5 becomes 4 plus 5, hence a 9. This number is about to get really big. I need 8 more after the 6. 1, 2, 3, 4, 5, 6, 7, 8. 1,600,000,000. 21. Let's get it. Oh man. I gotta recognize this, guys. Remember, when writing scientific notation, you notice it says 1.161. It has to be after the first digit. So what's going to happen is, even myself, the bearded math brother, may have that decimal in the wrong place when I'm writing scientific notation. So you got to remember that. You got to be careful with it, right? So setting up our problem, recognizing I've got a longer decimal, and something could happen here. And let's see what will happen. Let's break her off, meaning setting up the problem so that I can do my decimals, division of decimals, and then of course division of base 10 exponents. So 1.161 divided by 4.3, pull that calculator out. But before I tell you what it is, 10 to the negative, and that is a 9, be careful, over 10 to the negative 6. Got it. So again, guys, using the calculator to do my first bit of, whoa, what's going on there? Oh, had a little shift in the matrix. You know, red and blue pill. So, all right, use the calculator, 0.27, and this is what I mean, guys, by that decimal ain't working where it is right now. Not working at all. But let's see if I catch it and I fix it, right? 0.27 times 10 to the negative 3 power. Negative 9 minus negative 6. Because negative 9 plus 6. Negative 3. I did move it. I moved it because I knew I can't have 0.27 in scientific notation. It literally needs to be that 2.7 right after the first digit, right? So since I made the number bigger, moving that decimal changes your exponent. That's what we got, guys. So, and of course you gotta write it in standard form, but again, practice, guys. That's all it is, right? That's all it is. So we'll be doing that again. We've got at least 3 more of those. Go ahead and use all that good space right there, right? 22, plenty of good space. 4.625, 1.25. Do your division there. And then of course, I like this, 10 to the 10th divided by 10 to the 4th. Well, I just gotta know what 10 minus 4 is. Unlike the one below where you had some negatives to deal with, 10 minus 4, you ain't thinking too hard. That's 6. But you are thinking, where's my calculator? Because you need to do 4 and 625 thousandths divided by 1 and 25 hundredths. Which I love because look, it sets it up and gives it to me in scientific notation form, 3.7, right after the first digit. And again, that number in scientific notation needs to be written in standard form. So I'm going to move the decimal 6 places, telling me I need 5 more zeros after that 7. 1, 2, 3, 4, and 5. So 3,700,000, or 3.7 million. Again, dollar. 3.7 million is basically scientific notation, right? All right, well, where we at? 23. Again, getting the calculator ready because I do not want to have to do long division with 2 and 376 thousandths divided by 7 and 2 hundredths. I'm sorry, tenths. And 10 to the negative 4 divided by 10 to the negative 8. Slow down because the rule states negative 4 minus the negative 8, which will give me, as I'm being patient here, 10 to the negative 4 plus 8. So we'll get 10 to the positive 4. 10 to the positive 4. Then to write it out, need a little love. You know how the B and B do. 10 to the negative 4 minus the negative 8. And of course, now I know that's basically just saying negative 4 plus 8. And if I have more if I have more positives than negatives, really I'm not adding, I'm finding the difference. The difference is 4, and I'm going to write that as 10 to the 4. Now again, guys, 0.33 and needs to be 3.3. Alright? There we go, niggas. Smile out. Come on now. 3. There we go. Alright, so boxing and dropping. Alright, so am I gonna box that other one too? Alright. I'm okay. I need to write it out in standard form. You guys know that was part of the directions too. But I hope I'm doing a better job of giving you an understanding of this concept and the skills we have to use with the concept. I am writing that standard form down there, but I'm leaving us just with 24 now. And I believe that's the whole handout. A lot of times these handouts don't go past 20, 25, 30. It all depends on what the skill is. So 24, 8 and 74 hundredths divided by 1 and 9 tenths. And of course, we got to do our base 10, so 10 to the negative 3 power divided by 10 to the 5th power, right? And again, my brain, negative 3 minus 5, negative 8. But my brain is not doing that division of decimals there. So of course I pulled out a calculator and I got 4 and 6 tenths. And 10 to the negative 8 power. Let's go ahead and do a final answer because that works for scientific notation. But in standard form, we need to write that out as, now again guys, it's gonna get smaller, so 1 place for the 4 and then 7 more zeros. I mentioned that shortcut earlier, be careful. Shortcuts are avenues to mistakes, and we all make mistakes. Right? So stay away from those shortcuts unless you are so confident it's always going to work for you. And even when it always works for you, you can still mess up, right? All right, guys, scientific notation, something that is not complicated, but definitely has areas for you to slip, fall, but we always get back up. Thanks for coming out, guys. See you in the next video.